too far apart when it comes to figuring things out. This question is asking, okay, what is the hybridization in carbon dioxide? So first we have to figure out what carbon dioxide would bond as. So once again, Lewis dot diagram, and you know what that means, electron configuration, just to make sure we know how many electrons are out there. You can still definitely use your periodic table to see it right away, but you know, just a good way to just keep practicing this, writing down. So for carbon, it's helium, okay, and it'd be 2s2 2p2. Oxygen, started helium as well, 2s2 2p4, and we see here that carbon will have 4 in its valence, oxygen will have 6 times 2, that would be 12. So we have C. So in total we have 16 electrons we're working with. And as we said, carbon has 2 more, and oxygen has 1, 2, 3. The one that's left, because it's sharing 1, right? So it has 5 more. 4, 5, 4, 5. So these two will go in here, and these two will go in here. Okay, so in total what we get is C. Oops, we can't show that yet. O, and this is actually what would also count as a, even though it has polar bonds, still a non-polar molecule, because of the fact that now carbon, no lone pairs, and the oxygens are pulling equally at each other. So in summary, it would actually look linear, and that would be carbon. Okay, so now the hybridization, the way it works, right, is that in simple terms, really, there is a lot more complex that comes with it, but simple terms, when it has more than one bond, it starts hitting that p orbital kind of thing. So it starts as S, and then you add on to it. So S is like the 1, and then you see carbon has 2 double bonds, but these double bonds still count as 1 bond. Okay, even though it's a double bond, it still counts as 1 bond. So 2 double bonds, meaning there's now S, okay, and then P. That would be hybridization for carbon. Okay, now for the oxygen though, okay, this is where it gets even trickier, right? Lone pairs also count as a quote-unquote bond, okay, or at least a hybridization energy. So oxygen has 1, so start the S, and then it has that P, as in like 1 lone pair, but it has also another lone pair, so it'd be sp2. This would be the hybridization for oxygen. Okay, so hybridization is CO2, for the oxygen is sp2, for the carbon is sp. And exactly, carbon has sp, oxygens have sp2, which we found because of the Lewis dot diagram. Okay, and it says the sum of the numbers of atoms bonded to a central atom and the number of lone pairs is the steric number, which is what this is accounting for. So exactly, so that's why we have sp, sp, I mean S, that's what it starts with, and sp would be 2 bonds, sp2 3 bonds, sp3 4 bonds, and then when you start approaching sp3 like D and stuff, those are the ones that start breaking like the octet rule and everything. So they have the Lewis structure, perfect. So the carbon only has 2 bond groups, so it's sp as I said, and oxygen has 3, 1 bond group and 2 lone pairs, which makes it sp2. Okay, this is correct. 19 questions in. There's one question 20.